Now, our next topic is Gauss-Jordan method. So Gauss-Jordan method is basically some variant of the Gauss elimination methods, and let's see how it works. Again, let's consider a system of equations. It may be better if we speak over an example. Now, here we have a system of equations with three unknowns, and therefore we have three equations, as you see here. And next step is to write the coefficient matrix along with the right hand side of the equations. Okay, so it is 3 minus 0, 1, minus 0.2, 0.17, minus 0.3, 0.3, minus 0.2, and 10. And the right hand side is 7.85, minus 19.3, and 71.4. Now, first step is to normalize the pivot equation, scale the pivot equation. Sorry. So I divide the whole equation with 3 in this case, and as a result, I obtain the normalized equation. Now, after normalization, next step is the elimination of the pivot variable from the rest of the equations. Okay, so this is what we know from the Gauss elimination. Now we are left with such matrix. So the first equation is normalized. The second equation becomes 7.00333 and minus 0.293 minus 19.5617 and so on. And the third equation is also modified, and as you see, the coefficients of the first unknown is eliminated from all the equations. Now in the second step, again we normalize the second equation. First we scale it, we scale the second equation with the pivot variable. So this is our pivot variable, pivot coefficient. So the second equation becomes, the diagonal becomes 1, and the second term in the second equation, so the coefficient of the third variable becomes minus 0.041 in the second step, and also the right hand side will become modified minus 2.79 in this case. Now here is the difference. So remember that in the Gauss elimination method we have only forward elimination. Right? We have the elimination step. But in the Gauss-Jordan method, we do both forward and backward elimination. So we eliminate the coefficients, for example, in this case of x2 from the next equation and from the previous equation as well. So the matrix, the coefficient matrix become like this in this step. So the second one is eliminated. As a result, the coefficient of the third variable in the first equation becomes minus 0.06, and the coefficient of the third variable becomes minus 0.04. Now in the last step, we again normalize the or scale the last equation with the pivot coefficient, and then we will eliminate it from the rest of the equations. Now at the end, by using the elimination both in backward and forward direction, we are left with the identity matrix. As a result, the column vector of the right hand side will give us the values of the unknown variables. So it is 3 minus 2.5 and 7 for this set of equations.